prove by induction? We begin with letting n equal 1. Substituting 1 into the formula on the left, we have 3 times 1 minus 2. We're checking whether this is equal to, so I'm putting a question mark over my equal sign. The right, when we substitute 1 in, becomes 1 times 3 times 1 minus 1 all over 2. The left side is 3 minus 2. The right side is 1 times 3 minus 1 over 2. Left side is 1. We have 1 times 2 over 2. So 1 equals 1, and this is a true statement. Step number 2, we assume that the statement is true for n is equal to k. So we write assume that, and we rewrite the original problem changing out the n for a k. This becomes 1 plus 4 plus 7 plus plus parentheses 3k minus 2 equals k times 3k minus 1 all over 2. If you look at the top line of this column, you will see that all I've done is change out the n's for k's. Now we want to show that this will be true for the k plus first term. In other words, the sum of the first k plus first terms should equal what we have up above when you go up to the k plus first term. We know that this will be k times 3k minus 1 all over 2. Well, if we go to the k plus first term, this should become k plus 1 times 3 times k plus 1 minus 1, all of that over 2. So that's what we're trying to show that the k plus first term adds up to. Let's clean this up a little bit. We get k plus 1 times 3k plus 3 minus 1 becomes plus 2 all over 2. Now let's generate the sum of the first k terms manually. S sub k plus 1 is equal to 1 plus 4 plus 7 plus plus the 3k minus 2. There's our first k terms, and then when we add in the k plus first term, that'll become 3 times k plus 1 minus 2. I guess I need an outer bracket there. We know from up above that this is the sum of the first k terms. And we've already assumed in step 2 that this is equal to k times 3k minus 1 all over 2. We know what that's equal to. So let's add on this k plus first term from the line above, which is going to be 3k plus 3, then minus 2, which becomes plus 1. I'm going to put that over 1, and then we will add with a common denominator of 2. First term, numerator, 3k squared minus k. And in the second fraction, the denominator is being multiplied by 2, so the numerator is getting multiplied by 2, and this becomes 6k plus 2. Let's combine like terms up there in the numerator. 3k squared plus 5k plus 2 all over 2, and this will factor into k plus 1 times 3k plus 2 all over 2, and that right there is a perfect match with what we had up above as the sum of the first k plus first terms, and that tells us that we are done with our proof.